Okay, we're now going to work on converting from from rectangular to polar. You will need this extra formula here, r squared equals x squared plus y squared, kind of Pythagorean theorem. And all you're going to do is this. You're going to go to the first problem. It's 512. Remember, this is x and that's y. So r squared will be x squared plus y squared, or 5 squared plus 12 squared, which means r squared will be 25 plus 1, 44, meaning r squared is 169, so r is 13. And r is always positive, so I don't have to worry about the plus or minus 13, because I had to square root it to get the r. And now what I do is I come simply over here. I know the radius will be 13, part of the answer. To find theta, I know x equals r cosine theta. Well, x is 5, r is 13 cosine theta. Take 5, divide it side by 13. So 5/13 equals cosine theta. So to find the answer, make sure your calculator mode is in radians, and then do second cosine 5 divided by 13, close parentheses, and you will get a number 1.176, and that will be your answer, because it is in the first quadrant, so the positive radian 1.176 will be perfectly fine for an acceptable answer. All right, to work the second problem, it is very, very similar, except I might want to make a note, 1, -1 will be right here. I already know that's in quadrant 4. It looks like to me, just drawing a picture of it, I can tell that's -45 degrees, but let's show how to prove it and how to get the r value. First off, r squared will still be 1 squared plus -1 squared for the y, xy, which means r squared will be 1 plus 1. So r squared is 2, so that means r is the square root of 2. So I know the radian is square root of 2. And then I know the following. In order to find this answer, I might want to put my mode into degrees, because otherwise I'll get a decimal answer for the radian. I'm going to put my mode in degrees for the calculator, and I know this, that basically 1 over the square root of 2 will be my cosine theta. So I do degrees, second cosine on your calculator, 1 divided by square root of 2, close the parentheses, enter, and what you will get for that particular answer for cosine will be 45 degrees. However, I don't know whether it's positive 45 or negative 45 degrees actually is work, because cosine is positive here and here. The calculator only can do it in these two quadrants. And because I got a positive answer and my quadrant's down here, I know it's actually -45 degrees. Well, -45 degrees in radians is -pi/4. So I could have square root of 2 -pi/4 as an answer, or square root of 2 7pi/4, because those two are equivalent answers. They both would be correct. So now then, let's look at problem number 3. I'll still do the r squared equals the square root of 3 squared plus 1 squared, which will give me 3 plus 1. Square root it to get r, which makes the square root of 4, and the square root of 4 is 2. So I know this radius here will be 2, and what I'm going to do is this. 4 -1, if I I'm doing this one right here, negative square root of 3, 1, would put me in the following spot, right here. Well, I recognize that automatically with the square root of 3 right here. Look, there's the 60, the 30, 60, 90 triangle. So I know if this is 30, that means that's 150. I already know it's going to be 5 pi square roots of 6. But what I would probably do, to be sure, if I want to go to my calculator, is I would do second cosine, and I would probably keep it in degrees. And what I would get for an answer here, I would do the x value, which is negative square root of 3 divided by 2 in parentheses, like this, enter on the second cosine, and it would show me 150 degrees on the calculator, which 150 degrees is 5 pi over 6. So that's how you do that with the calculator. And now to work the last one, right here, or work it right here, r squared will be 4 squared plus 1 squared, or actually negative 1 squared. Make sure you put it in parentheses in your calculator, or you'll get the square root of 15 instead of 17, because 4 squared is 16 plus 1 means I'm doing the square root of 17, so r is the square root of 17. I already know the radius is the square root of 17, comma, and now I need to find the other one. I would probably on this one put my calculator back into radian mode, because this is not going to be an exact answer. And in radian mode in my calculator, do second, and because I'm in quadrant 4, negative 1, if I graph it, I know I'm here. I would probably use the sine feature. I would go second sine, because I know that would give me the better choice. And the sine value would be negative 1 divided by the square root of 17, enter. And if I use second sine on that, with that enter, I will get negative 0.245 radians, which I know is correct, going down from right there. That would be the perfectly fine way to do that. Make sure you can make your calculator back and forth between degrees and radians to know exact answers. So you'd probably be in the radian form, and the other one could be in decimal type form.